Hello, my name is Whisker Rabito, and we're NASA 2.0. As a team lead, I had the idea to create a long-range navigation system, which was the communication between a rover and the drone. The drone was tasked to basically search the area for any objects in its area and communicate to the rover. Now, several hills we had to overcome were time constraint, coding knowledge, and also faulty materials. The team members are Chris Borja, Salvador Martinez, and me, Luis Garabito. Now, initially, our project, we were to create an Arduino board. We were to use an Arduino and hook it with the Bluetooth module on the drone to communicate with the rover down below. Unfortunately, when we got the materials, we saw that they were too big to actually put on the drone. So we had to approach this project in a new direction. But as we thought of a new solution, object tracking, that was also not working out. So we had to simplify the project even more. Instead of making it autonomous like we wanted to, we had to basically make it pre-programmed. So we would have to have the drone fly up, scan the area, come down, and then have the rover move forward, stop, turn right, and let the drone once again survey the area until it's finished. Now, problems or several obstacles I had to overcome while creating the rover were that the first version of the rover was not working well. The motors weren't working well. The wires themselves were pretty bad, I believe. And then the second problem was that my Arduino SparkFun board got fried, so it wasn't allowing me to proceed with the project. So what I had to do in order to circumvent this problem, I had to actually buy an Lego Uno kit, which allowed me to build and program a rover, allowing me to continue with this project. Now, several things that I actually learned in this project were how to use multiple driver shields. I learned about what an H-bridge and how it functions. And I also learned more about the Arduino in general and different types of Arduinos and drones, of course. The experience of this project, what I've experienced was frustration, fulfillment, and overall satisfaction with what we have. I feel very honored and also very, very happy with what we have. And not only that, I'm also very satisfied and very exhilarated to have met all these people and create these new bonds.
Hi everyone, my name is Cristal Borja and I was responsible for programming the drone. I'm very new to Python programming, so in the beginning it was a bit of a challenge. However, I was able to use PyCharm IDE to control the movements of the drone, how high it flies, and also object track. When working on the drone, I did encounter a couple of issues. For example, the battery life was really short and the drone seemed to overheat quickly. To resolve these issues, we assumed in the beginning that the overheating was caused by the battery. So a teammate of mine did order an extra battery to see if that would help the issue. However, it didn't and the overheating persisted. So to fix that and the battery life, we tried to use a simpler code to let the drone, or to make the drone not use as much energy. We also noticed that weight on the drone did drain the battery life. So to fix that issue, we did remove the propeller shields from the drone. We did use a simpler code to save energy from the drone as well. In the beginning, we did have the drone working autonomously. However, we've been having errors with our code, and today we weren't able to get the drone to work on its own. So instead, my teammate Saul will be controlling the drone through his phone using the Tello app. Thank you.
Hello, my name is Salvador Martinez, and I helped out with the drone on this project. Our first approach to the project was to mount an Arduino and an ultrasonic sensor to the drone. We found out that we can actually use the OTG cable to power the Arduino and the sensor using the Tello battery. But unfortunately, we realized the propellers were too noisy to be able to use the sensor on the Tello. So we scrapped that plan. And we decided to use a Tello camera instead. The way we approached it is we used TensorFlow with Python to be able to detect objects and send that information back to the rover. We wanted it to be able to detect objects and maybe even possibly cliffs, so the rover would know the best way to maneuver around. Another big issue we faced was the Wi-Fi connectivity. We tried to use a Wi-Fi module with the tello to get a communication, but unfortunately we could not get the communication. Even though we were unsuccessful with how we wanted the project, we still learned a good amount of coding, especially with the tello. We were able to make it fly, land in different locations where we wanted it to. And for future projects, we would actually like to make the TensorFlow work on the tello and also be able to land the drone on top of the rover, so it would be more of a one unit thing.